So, let's talk a little bit about the technology that we're using under the scenes and who TechSoft 3D is. So whether you're an existing partner or just somebody who's interested in our technology and maybe wants to do an eval or just learn more about it, the one thing that you should know is TechSoft 3D is here to fuel innovation with our unmatched technology. And that's really how we see it. We have these great products, the HOOPS product line for native applications that want to use 3D, web applications that want to use 3D, and a lot of stuff for 3D data translation and all that. So today we're going to focus a little bit more specifically on our HOOPS Communicator software, and that's basically what we're going to be containerizing. So what you can expect today is basically a little touch up on, how did we get to this virtual training series? What were the prerequisites of it? I want to talk a little bit about, container technology, what and why we're using it, and, just a little bit of background on that. And then we'll actually get into Dockerizing that application that I've sent out to everybody. I want to give you guys, just a little bit of a, here's what we're doing in TechSoft for Docker. Here's some of the use cases that we found for it, and then just throw it to you guys for a Q&A if that's questions about, specific stuff to TechSoft, if it's stuff specific to Docker, just kind of, chat about stuff if everybody wants to. If not, feel free to get on with your day. So what is container technology at its base? And I say this jokingly, and I say this not jokingly. To me, container technology is sort of like Inception for virtual machines, where you basically just have this layers and these layers of these containers that are basically, nested and linked together. And at the end of the day, what they give you is a full-fledged application with a base OS and a kernel space and user space and all that stuff. And the goal of this technology is, or at least the value that I see out of it, is eliminating the problem of, I've created this application, it works on my machine, I deploy it to QA or production or staging, and it doesn't work. Why is that? Well, containers and those layers of dependencies, they kind of really isolate everything that your application needs, and it bundles it in a really reliable and reproducible way. So if you have a Docker container, you can be sure that it's going to run the same on your machine. It's going to run the same on your coworker's machine. It's going to run the same in your cloud environment. It's going to run the same everywhere. Of course, that's the best case scenario. I'm sure there's situations where stuff goes haywire, but for the most part, you can assume that it's going to run everywhere. And that's a nice peace of mind to have as a developer, especially when you're trying to get features out fast, or you're trying to get bug fixes out fast and all that. So why use it, right? I mean, I just gave you a few reasons. These bullet points are kind of my point of view, some of the reasons that I really like working with container technology. And the first is that containers have this big open source following, right? You have, Docker getting spun off, into an open source project like Moby that basically allows the community to implement features that they want, to report bugs, and to kind of control the direction that this technology goes, because they're the ones that are using it. And if anything, open source technology is gaining a lot of momentum. It has been for a while. I mean, Linux, right? Like the Linux kernel is open source, and that's a pretty good example of when you get a technology that's widely adopted by a community and widely contributed to, you get a really, really high quality piece of software that can be used for decades successfully. And kind of going along with that talk on containers, and you have these layers and layers of dependencies. One of the other things you get out of it is increased security and increased reliability and deployment in a cloud environment. The way that it's structured, you just don't have these, like your root application can't directly access, the kernel space and all that. And so that's kind of where you get some of these security enhancements. They're just natively built in to the technology, and you don't really have to do anything to get them. And that's always nice when you get a free lunch and you don't have to do anything. And then not lastly, but containers are really scalable and really reliable. So in a cloud environment, you have an application You just made the New York Times front page and you're getting, 5,000% increased traffic. Well, you can just set it up to spin up as many more containers as you need to handle that, right? And then when that need goes down, you can scale them down. So containers are sort of the cloud's best friend, in my opinion. And this is a technology, and a lot of these use cases are stuff that some companies don't really realize that they need until you get off the ground, your application gains steam, and then you're like, oh crap, I could really use some of them containers right now. Sprinkle a couple of those in here. So it's good to be ahead of the curve, or to at least have your foot in this pool and to know what container technology is. Because the truth is containers they're not a one-stop solution, right? Some people have applications that containers don't apply to. Some people have applications that could really benefit from containers. So by exposing yourself to this technology, knowing what it is, hopefully you can make that more informed decision of, is this the right solution for me? Or should I maybe look for something else? And then my personal favorite reason for using containers is the cross-platform development. So like for today, I'm on a Windows machine, but all of the containers and applications that I'm building are targeting Linux, and it's really easy to do. So it's really nice being able to work on a Linux application from my Windows PC without having to SSH into a VM or have to worry about WSL working and having all of the Linux functionalities that I need. So it's really cool to be able to work from one machine and really target, base OSs of anything from, OpenJDK to Linux to Alpine Linux to Ubuntu, all sorts of flavor of the month operating systems. You can work with them all. And then for those of you that are working in a cloud environment, there's the whole push for continuous integration and delivery, right? I'm a developer. I want to write code. I just want that code to work with my version control, that when I push it, my code gets deployed to a staging or production environment. I don't want to deal with SSHing into servers and installing dependencies and pulling the most recent and making sure that I have everything working. You can just push your container and run it, and that's it. So those are some of my personal reasons that I like working with container technology. And I think if you guys work with them, you probably agree that these are some of the big bonuses of it. So, with a little bit of background on what the containers actually are and what technology we're going to work with, without further ado, I'd just like to jump into, applying Docker to this skeleton project that I've sent you guys. If you don't have it downloaded, no fear. We'll post some of this stuff later. This will all be recorded. So feel free to just listen for now, and then you can circle back later and give this a shot if you want, or reach out and we can help you with it in the future. But for those of you that have the application up and are maybe looking at like the directory structure, what I've sent you is basically an application that consists of two different components. There is the first component, which is TechSoft's HOOPS Communicator software. HOOPS Communicator is basically going to be what's powering and what's serving the 3D data to our 3D web application. And HOOPS Communicator also includes the front-end JavaScript dependencies and the libraries that you need to get HOOPS Web Viewer up and running inside of your web browser. So the graphics that you see displayed in this demonstration are going to be served from HOOPS Communicator and basically rendered and visualized with HOOPS Web Viewer. Excuse me. So that's the HOOPS Communicator project, and then the other project is just the server directory. And all that really is a basic Node Express application that's basically just listening and serving some static HTML on the root path. So really nothing fancy for that 3D web application. But I think what's important for you guys to know is you should treat Communicator as our side of it, and you should treat the server as your side of it. So in that server project, that's where you can go crazy. You can do whatever you want. That's where you can innovate, and that's where you can do some really cool stuff. So that's what we want you to help with, that's what I want to help you focus on, is not worrying about that HOOPS Communicator side of things and just being able to get up and running and developing your application with a lot of ease. So those are our two components. what we need to do is we need to build a Docker image independently for each of those. We should be able to run those by themselves. And then after that, we can use Docker Compose to basically declare this as, hey, this is a project. These two Docker containers are related, and we want to run them together, spin them up, spin them down, build them, push them, pull them, all of that stuff. So we're going to use Docker Compose to build them. We're going to use Docker Compose to run it locally. Hopefully you guys can follow along there. You can see it running locally. And then I'm going to take it a step further, and I'd like to push these Docker images to our AWS repository. And I hope to be able to deploy them to a server in real time for this demonstration and kind of show you guys how, how convenient this is to work with. So without further ado, I'm going to kind of just jump into the project. Let me resize this. And let's go ahead and let's just see what we have going on here. So your folder that you have may or may not look a little different than this. There might be a couple of files. I apologize for the inconsistency, but the core of it is still there. Just going from top to bottom here on these directory contents, we have our Git stuff. Yeah, that's great. You probably already know about that. There's this AWS Commands folder. That's not really important for the context of you guys for this demo. That contains a couple of shell scripts that run some AWS CLI commands to basically spin up AWS resources that we can host and deploy these containers to. So if you have AWS and you want to see what that looks like, feel free to look at those. If not, just disregard them. And then next we have the communicator. This is the HOOPS Communicator component that I was talking about. Then we have our Docker Compose file. This is what's going to basically control and allow us to spin up and down our two communicator and server Docker files together. The ECS params YAML, you guys can ignore. Don't worry about that. That's more AWS stuff. And then lastly, we have our server, which is the 3D web application that you are creating to integrate with HOOPS Communicator. So let's focus first on getting HOOPS Communicator working and building and running in a Docker file. Then we'll do the server, and then we'll do them both together. So I'm going to go ahead and I'm going to go into the communicator directory, and you can see here we have a Docker file, we have models, server, web viewer. Models is the 3D web data, or sorry, the 3D CAD data that we want to stream from HOOPS Communicator into your front end application. Web viewer is those front end JavaScript components that are going to allow you to create the HOOPS web viewer instance in your front end JavaScript, served from that static HTML, and actually render and interact with these 3D models. And then server is all of the low level TechSoft HOOPS Communicator, like the actual logic behind it. So that's where we're actually going to be running our application in. So right now, if I go ahead and I open up the Docker file that we're going to use to build this, you guys, if you have this, you should have an empty file as well. So for the purposes of this demo, I obviously have most of this stuff written already. I'm just going to be kind of pulling some commands over line by line so I don't fat finger anything and have some syntax errors later. But if you have any questions about any of the stuff that I'm pulling over, drop it in the chat. I'm happy to expand on it. So we talked earlier about Docker being these layers of containers. Well, we have to create that first layer, and we have to basically explicitly say, this is the base OS that I want to run my application off of. So for HOOPS Communicator, I've found that the OpenJDK 8 base image on Docker Hub has all of the underlying Linux components that we need. It works really well, so we're going to go ahead and use that. So basically that gets us our operating system. Now we need to start layering in our dependencies, add in our application, and we're ready to run it. So for an OpenJDK, these are just kind of some housekeeping commands that you would maybe run when you first provision a server. We want to make sure that we have all our packages set up and ready to go. This stuff is just a little bit more boilerplate. Apt-get update, make sure all the packages are good. So now we can actually start layering in our specific dependencies that we need. Now, HOOPS Communicator is powered by a node server. So we're going to go ahead and we're going to install Node into our Docker container, or into our Docker image. apt-get's going to give you, apt-get is going to give you Node 10.19.0. HOOPS Communicator officially supports 10.16.2. From my experience and just for the ease of this demo, I've had no issues with 10.19.0. Don't quote me on that. But we're just going to be using that for this. You could specifically target 10.16.2 if you wanted to use this in the future, just to ensure complete compatibility. So right now we've got our base operating system. We've got Node installed. So all that we really need to do is we need to copy our application code over and we need to run it. And it's really as easy as that. So to copy our application code in, we're going to go ahead and we're going to ask that we copy in everything from the root file, or from the root directory of this Docker file in. This is going to recursively add everything in there. And then after we have all our contents in there, we want to describe to this Docker file where we're actually going to be running our application. So op virtual training Docker is where we copied everything. Within that, we have that server, that HOOPS Communicator server, and then in there, all the logic is down in the Node directory. So we're saying, hey, that's where you want to be running stuff. And then lastly, we need to tell our container when we run it, what do we want it to do? So we're going to say, okay, when we run you, this is the command that we want you to run. And this is what that startup for that is going to look like. So this stuff should all be laid out for you. That config file should have everything you guys need. So if you have this and you're following along, we should be at a point where we can go ahead and we can quit out of this. We're still in the same directory and we should be able to run a docker build -t, sorry, not IT, -t. We're going to name our Docker instance, or sorry, our Docker image so that we can reference it later. So docker build.t, communicator Docker, and then we need to point it to the Docker file that we want to build with. So by default, it searches for a Docker file. We're going to tell it to do it in the current directory. You can explicitly tell it to use a different Docker file in a different directory with -f or something. It's best just to keep it in here. So if we go ahead, we should be able to build this. You can see it runs through all of our steps that we declared in that Docker file. I've built this previously. So if you're building this alongside me, you're probably actually going out to Docker Hub. You're getting that OpenJDK. You actually have to run through all of these run through all these steps. So right now we're done. I am done. You guys might still be going, but we're going to continue along. So now that we have that Docker container built, all that we have to do is run it. It's just a simple command to show that we need to run it. In order to actually interact with it, we would have to specifically specify some ports that we wanted to run on, but that's not important right now because these two aren't communicating. So now you can see that we basically have our HOOPS Communicator instance running inside of a Docker container here on our machine. Super easy. Nice. I love it. So that's one of our components Dockerized. We need to go ahead and we now need to switch into the 3D web application that's being developed. We need to Dockerize that. And then we should be able to use Docker Compose to spin these up and down together. So back in the root directory, I'm going to go into my server that I have, my 3D web app. And in here, I said earlier, it's a basic Node Express application. If you're not familiar with Node, I'll just go ahead and give you a quick lowdown on these files and what they are. We have our Docker file, of course. We have our index.js. That's the entry point to our Express application. It's basically going to spin up that application listening on port 4000. It's going to serve a couple static files, and that's really it. The biggest file it's going to serve is that static HTML. That's going to actually render that HOOPS web viewer and allow us to communicate with the communicator instance we just Dockerized. We have our Node modules. Yes. We have package JSON. This is all standard Node stuff, so don't worry about it too much. Package lock JSON, the dreaded file of all Node developers. We have our public directory where we're serving our content from. And these last two, don't worry about those last two. So in order to go ahead and Dockerize this one, we're going to go into that Docker file. Again, you should have an empty file if you're following along. And we're going to go ahead and we're going to start getting this going with Docker. Let me drag around some stuff. Okay. So like we did with the last one, we based that off of an open JDK instance because that is the base image that satisfied the requirements for that application. For the application that we're doing now, we don't really need a super involved Linux subsystem and all these weird dependencies. We just need something that's going to run Node and it's going to be easy to use. So Node has basically these really small optimized Alpine Linux instances that have the Node version of your choice installed. So like I had said earlier, we're going to go ahead and just use 10.19.0 just for consistency throughout both of our applications. So we declare that that's where we want to pull from. And then we don't really have to do any setup because we're just running a Node application, whereas the HOOPS Communicator Docker image was actually like using underlying Linux libraries and stuff. That's why we did the apt-get update and all that. We don't need to worry about that. So we can just jump straight into dumping our source code into this container as we did. After we dump it in there, like we had said, we need to tell it where to run everything out of. One thing to note, HOOPS Communicator ships with all of its Node modules and all the server dependencies bundled so that you don't have to install them and worry about version conflicts and things being deprecated and all that. But for the purpose of our application, we probably have some build instructions that we need. Whether it's Webpack stuff or it's npm install or whatever. So this would be the place to take care of that. All that we need to do is we just need to run an npm install, get our Node modules, and that's pretty much it. Our application is ready to run. The next step is just like we had done before. We need to tell our Docker container, when I tell you to run, this is what I want you to run. So this one's a little bit more short and sweet. That's pretty much it. So like we did the last one, we should be able to build this. So I'm going to call this virtual training app. We're going to ask it to build, tag it, and target this Docker file that we just filled out. Again, a lot of this stuff that I have is cached. You can see it just ran an npm install, boom, so we're good. So now I should be able to Docker run virtual training. I can type virtual training app. And boom, look at that, our app is started. So what we have now is we have our application running inside of Docker. We have Communicator Dockerized. Communicator's not running right now. But if I go ahead and I come over here and we go to $4,000, of course. Oh, that's right. So this is what I mentioned earlier. When you run it, you need to explicitly map the ports for the container to your host machine. That's a little gotcha. And you actually need to run it. That definitely helps. App started. Boom. Okay, so here's just our basic web viewer app. This is our front end. This is your application. Right now it's saying it can't connect to the HOOPS web viewer instance, or sorry, to the HOOPS Communicator instance, and that's because we're not running it. So now, in order to run both of these side by side, what we need to do is we need to use Docker Compose so that we can basically stand our two containers up simultaneously. So let's go back out to our root directory where we have our Docker Compose file. Again, it's probably empty for you guys, as it should be. So let's start filling this in. This one's going to be a little bit more up in the air. There's a couple intricacies in here. I'll expand on them, but just don't get too worried about anything. So first, we're targeting the version of Docker Compose we'd like to use. We want to use Docker Compose 3. Next, we need to define the services that this Docker Compose file is running. And this is basically defining, hey, what Docker containers do you want me to run? So we want to run one called Communicator Docker. Actually, I'm going to call it Calm Docker because that's what I did before for consistency. And we're going to need to run one, and we're going to call it our virtual training app. And that's the app that you see over here. So then you need to define some things for each of these Docker containers to run. So I'll just go ahead and I'm gonna do the same thing. So I don't fat finger anything. So, for our communicator Docker container, we basically saying, okay, so where is Docker Compose building this from? So I'm just passing it the relative path from this root directory to that communicator directory where that Docker file resides. Lastly, or sorry, not lastly, but next, you need to name the image that is going to be built. And this can also be used to integrate with Docker Hub. So the name that you're going to see me throw in here is not too visually friendly, but basically what it's allowing us to do, this is the name of Amazon Elastic Container Registry, which is basically GitHub for Docker containers. And this is going to allow us to use Docker Compose to push and pull the images that we build to the repository that is declared here. And then one of the things I had talked about earlier is you need to manually define the ports that you map from your host machine to your container. So let's go ahead and do that. For the purposes of HOOPS Communicator, we need a couple ports. So we need 11, or we need this top two are what's going to be, what are going to be allow us to be able to communicate with HOOPS Communicator. And then these ones down here are the ports that we're actually going to be streaming data back and forth to that server with. So that's all the configuration we need to do for the communicator Docker file. But now we need to do the same thing for our 3D web application. So just as we had declared that we want to build a communicator from the communicator directory, we want to build our application from that server directory that we have. And again, I need to name it. I have my name set to that same thing, just another application in this Amazon ECR repository. And then lastly, we need to map the ports for our node application, just like we did our communicator application. So here we're doing 3,000 and 4,000. We could just do 4,000, but sometimes I run on 3,000, so I'm just going to leave that in there. Now that's our Docker Compose file, right? We're just saying, here's the Docker Compose version to use. Here's the definition of my two containers that I want to run. Bada boom, that's it. So now if we exit out of here, we're not using the Docker command anymore. We're using a Docker Compose command. It's a separate CLI. It was developed independently from Docker, and it gained enough traction that Docker themselves actually, I don't know if they acquired it, but they basically, it's now integrated with Docker. You install it from their website and all that. So you should be able to run Docker Compose and see all of the commands. So for our purposes, let's go ahead and let's do a Docker Compose build. We had already built those two images independently, so it's just going to use those cache version. There's been no changes in them. So here you can see basically with this single command, we built our Docker image 1, and then we built our Docker image 2. So we can specify that we would like to now Docker Compose, we would like to run these. So you do that with Docker Compose up. Boom, boom, boom. I think I might already have, excuse me while I do some cleaning. The ports are taken because I have stuff running. Kill a couple of these. Bear with me. It never, I guess one of the other benefits of using Docker is you get all of these really cool names. Okay, we need to kill 2 more, and then we'll be good to go. I apologize. Kill that one, kill this one. Alrighty, so now if I run Docker PS, this is basically, running it's listing all of the Docker processes I have running. So you can see right here, we still have that virtual training app instance running from our previous command. So that is what is conflicting me. If I go ahead and kill that. All right, clean slate, we're good. So now we can run a Docker compose up. We see our virtual app is started. We see the HOOPS Communicator server is running. So now if we navigate to that same application, you can see that basically what we have done is we've created our front end application. We have HOOPS Communicator. That front end is requesting the streaming in of this 3D model from HOOPS Communicator. It's streaming it in. Those two Docker containers are running side by side and fulfilling their purpose. So, if you've been following along and you are at this point where you're seeing what I'm seeing, congratulations. That's really it. That's our goal. You have basically taken container technology and applied it to the HOOPS products, and you now have your application running inside a container. So what I'd like to do now is basically take this this container that we have, these two containers that we have, maybe go through some of those AWS steps that we have and see if we can get this running on an AWS server. I will say that it's going to be a little bit more, I'm just going to be running some commands. So if you want to have any questions, you want to drop in the chat, now is a good time to do so while I'm going forward and getting the rest of this set up. So before I run the AWS commands, I just want to show you guys what's in them. There's two files in here. There's an AWS setup. Basically, this is going to use AWS's Elastic Container Service to set up a server for us where we can run our Docker containers. There's a little bit more behind the scenes for our AWS account that's going on here. Like we're specifying some of the security rules, which VPC or which kind of like virtual gateway that we want to run it through. So if you're just copying and pasting these commands, don't expect them to work. I also have the AWS CLI on my machine, already configured with credentials and all that. So this won't work out of the box for you, but if you reach out, I'm more than happy to help you set this up if this is something that you need to do. So what you would really do is you would run an AWS setup command. You would execute these two. It would go out to AWS and it would start provisioning all of these instances. I have already ran these commands and this cluster is already up and running because it takes about 15 to 20 minutes for AWS to provision the EC2 instances and get everything set up. And in interest of time, it's easier to just set it up beforehand. And so after you have those resources set up, we're going to be interested in starting our containers on those AWS resources that we've created. So you can do that with ECS Compose, which is basically a Docker Compose interface into AWS. So, and then this last one is just like that same PS command I ran locally, like, hey, show me what's running on this. So if I go ahead and I was to target this, if I was to target this and let's say, hey, what's running in our cluster? You should see that really nothing is running in our cluster. So here's our server. This is the AWS instance that's been set up over here at 54, 188, whatever. Right now, there's nothing running. So in theory, we have our Docker containers. Let's just build them one more time. This is kind of what you would do if you were to make changes. You would build your changes. Then you would ask Docker Compose to push because my image names are my EDR repositories going ahead and I'm just pushing them straight there. I think if you had a Docker Hub account, you could probably use that registry name. I think Docker Hub is free. You could use that registry name and push easily to there. So basically, this is just, I think we've made some changes to our Docker file and a couple of those. So it's only pushing what it needs to push. It's not going to re-push your base OS. It's not going to push your node modules if that hasn't changed. It's just going to only push the part of your container or the layer of your container that's had file system changes. So once this builds and pushes, we can basically go back to our startup command, and in theory, we should be able to run it, and we should be able to see these containers launched in our AWS account. In the meantime, while that's pushing, let's just go ahead and I just want to touch briefly on, kind of TechSoft and containers and what we're doing. Sort of new to us. We have our software is, we have solutions for web, we have solutions for mobile, we have kind of solutions for a lot of different areas. So it's not like Docker is really a one size fits all for us, but we're trying to find use cases for it. So, I've messed around with some of our other products, HOOPS Converter, which is our 3D data, like kind of translation tool. You can get that running in Docker too. So there's really no, I guess our products aren't really limited in Docker. It's more of if Docker and our technology is a right fit for you, then it's good to use it. It might also be possible that you just need to use our technology without containers involved. But I think we're going to be kind of updating everything that we're doing around container technology and just cool TechSoft work at this URL here, our labs.techsoft. So if you want to stay in touch or see what we're up to, that's kind of a good place to go over and just see what the TechSoft community is working on and creating and all that. All right, so hopping back over to the CLI, we can see that everything is built, everything is pushed, everything is up there. So we should be able to use that AWS startup command to compose up. So if we do ECS CLI compose up, supply some flags, and then basically target the ECS cluster for our application. It's basically going to go out and it's going to try to get this running. So right now you can see it's waiting for them to be running, waiting for them to be running, waiting for them to be running, and they are running. So the moment of truth. Oh, that's unfortunate. Oh, excuse me. I forgot. I'm running on my local branch right now. What I need to do is I need to go to my good branch. There's just like some URL things that in a production environment you would have set to target the right URLs. For the purpose of this we don't have it. So let's go ahead and let's redo this. I apologize. And we're going to build it again with our good URLs for production, and we're going to push it. Alrighty, and now we want to go ahead. Bring down the container that we ran up there that has the bad URLs in it. And over here, I'm actually SSH into the EC2 instance that we're running on. So here we can see that there's some stuff running. So for time's sake, I can actually just pop over here and I can just kill it. Okay, I guess it got killed already. All right, now let's try to bring it back up. Boom, they're both running. And boom. Okay, cool. So now you can basically see that out on our EC2 instance, running at whatever this address is, you guys should be able to go see it. I don't think there's any internal or private restrictions. Basically, we're out in production or a QA or staging environment, and this is all working there just like it worked locally, besides the little hiccup of some host names. So, I guess that's just, I kind of wanted to do that to show you guys the value and to reinforce that if you're using containers, integration into a cloud environment is really easy and really simple and pretty pain-free. So if that's something you guys are interested in or you guys want to know more about, feel free to let me know. reach out to me directly if you guys would like more information or just kind of a refresher on any of this stuff. But for the purpose of the demo, I think that we've got kind of everything out there that I wanted to get. If it wasn't concise or clear, I apologize. I'm happy to clarify later. But if you guys have any questions, I see one in the chat now. Feel free to throw them in there. I'll let those aggregate for a minute as I kind of close this out, and then we'll circle back and we'll grab those. So, if you're interested in this, if you kind of liked what you saw and you want to know how this can help you, if you're an existing partner, reach out to our marketing team, reach out to our consulting team. We're always here to help you. We would love to work with you guys on kind of, this new chapter of technology and how we can kind of get it integrated. If you're not an existing partner and you have an interest in HOOPS products, I'd recommend you go start an evaluation with them. You can get it's a free evaluation. You can get full access to the product, and you can basically see if it's the right fit for you and see if you like it. It's worth noting that this project that I shipped out to you guys, I think will be good through June 22nd. So if you want to try to get this up and running before then and show it to somebody or say, hey, look at this cool thing that I did, you have until the 22nd to do that. But if you start an evaluation, you can basically extend that time. But we have a few other ways, like Innovation Labs. I dropped that link earlier. Feel free to check that every now and then for cool stuff that we're doing. That's kind of a new thing for us, but we want to start using it more. We have these virtual trainings going on right now. There's another virtual training that's happening next week that Jonathan is actually leading. So I'm gonna pass it back to him for a minute, and he can maybe talk about what to expect there, and if you guys are interested at all.
Yeah, that's awesome. Thanks, Tony. So yeah, that was fantastic. We do have a couple other events coming up. We have tomorrow. You can register on our website for Talk About Manufacturing in the Digital Factory. We also have let's see, yep, mesh processing next Tuesday at the same time. We'll be talking about Polygonica. A couple other things, like use the package that Tony provided to you and get working with that. We also just released in the most recent release of HOOPS Communicator, that's our cloud and web-based visualization tool, a set of Docker images that you can pull down from a Git repository. So you can use his template. We also have a set of templates that we ship with the product. Check that out. So it's something that we can do. Any other questions? I'm also curious, like what it is that you guys want to be doing with Docker or web technology. So if you want to share your interest there, that would be fantastic. And then lastly, this is going to be up on our YouTube channel, so you can replay it and work through this example that Tony walked us through. But thanks, that was fantastic. Tony, I'll let you answer the few questions that are here in the chat. There's just a few, and we'll wrap it up.
Yeah, cool. All right, so I'm just going to go down these in order. So reading them out. So in your case, the models which we see on the 3D viewer are already on the communicator instance. Somewhat. Oh, I'm realizing I'm not sharing. Let me just share one more time, and I'll just show you where these are at. So we had our project. I'm in the root of it, and I go into our communicator directory, and in here you see a models directory. And if we look at that, oops, it helps to actually target it. You see here we have two of these SCV files, which is a stream cache zip. A stream cache is a internal HOOPS format. So HOOPS Exchange converts to stream cache, and then HOOPS Communicator serves stream cache files back to the HOOPS web viewer. So this is all an internal file format that you can get by using HOOPS Exchange. HOOPS Communicator does not stream just like .cad files or something. It does a conversion to our internal format first. So yeah, to answer your question, those files that were in the HOOPS Communicator instance, and were basically manually added to that container. So that communicator server is reading them from its local file system in that image and serving them from there. Docker gives you the ability to mount volumes and all that. So it'd be possible to do this in a way where your communicator instance was actually targeting a remote folder, right? So you could drag and drop models in there and get them served without having to reload your communicator instance. Regarding, I hope that answers your question. If not, feel free to get back. And then Goran asks, on slides with other examples, there is converter as a service. Where can it be seen? It can't really be seen anywhere externally. It's sort of an internal project that we're working on. But if you are using HOOPS Converter, there's nothing stopping you from using it like that. So that's something you're interested in. Again, please feel free to reach out to us, consulting, or to myself, and I'm happy to elaborate more on that. Dave says, great presentation, thanks. Thank you, Dave. Appreciate you being here. Julian asked, can you share the final Docker files and compose files? Absolutely. What I will do is I will take my good branch that I have, I will zip it up, and I will replace, I will replace the Amazon S3 link that I gave you guys with that good completed one. Maybe give me till about the end of the day today. We'll probably keep hosting that link through the 22nd when that license and that communicator instance is good for. So just go out there, grab it, that zip again tomorrow. If you don't have the zip, let me just go ahead. If you don't have that URL, I'm going to go ahead and repaste that in the chat. You can reach out to that URL and get that zip file. Okay, we have visualization files on a third instance where we store files. So my question is, what would be the best way? Okay, yeah. So I guess I kind of answered that a little bit, but let me elaborate on it a little more. So if you have this communicator instance running on a container, and you have like a third instance that's just like a file storage instance, with Docker, you can create the notion of a volume. And then you can mount a volume to a Docker image that's running or to a container. And basically, then that container has, just like the same on Windows, if you map an external drive, it's kind of that same logic. So it sounds like maybe you could use that, map that third instance, and then just be able to manage your files inside of that volume and not have to worry about redeploying your communicator image in order to pick up those changes. I'm just speaking on that off the top of my head. Don't quote me on it, but again, reach out if you have questions or you're trying to do that. It sounds like a really cool use case, and I'd be happy to work with you to get that going. And then Stephen asks, when will Communicator be able to serve SCZ files from Amazon S3? Oh, that's a good question. I think that let me see how to answer that. I think that there's things that you could do to get that functionality, but that actually sounds like a really cool idea for kind of Communicator, as a service. But I don't know, I'm in marketing, I'm not in development, so I can't promise any features or anything like that, but, maybe stick around, keep bringing that up. It sounds like a really cool idea. I'd see a lot of value. So good question. Well, I'm not seeing any more in there. Feel free to drop them in. If you want, I'm gonna go ahead, I'll just drop my personal email, or my company email in there. So if you have any more questions, feel free to grab that, email me. I can direct you to who can answer them, or I can help you try to answer them myself. But yeah, I really appreciate you guys being here and taking the time out of your day. Like Jonathan said, I think we're really interested to see what you guys are doing with Docker. So, we love it if you guys reached out to us or, reached out to me and just said, hey, this is our use case for Docker. This is why we were interested in this session, and maybe we can do some more in the future to try and help you guys out with the applications you're trying to create. But Jonathan, if you don't have anything else that you'd like to say, just, thanks everybody for being here. Stay safe out there, and we look forward to seeing you in the future.
Great. Thanks, Tony. Thanks everyone for joining us today. Take care.
Thank you. Bye-bye.
Bye.